everyone, and good evening to everyone, and welcome to EduAdvisor Webinar Central, the platform will bring you topics you care about, delivered by industry experts. I'm your host, Lina, and before we dive in, let me quickly introduce EduAdvisor, your go-to platform for making smart education decisions. Now, whether you're exploring courses, comparing unis, or looking for scholarships, EduAdvisor is here to guide you every step of the way. You can also check out our career tools, exclusive webinars like this one, get help with the PTPTN application, or speak to an education consultant for personalized advice. Plus, if you apply through EduAdvisor, you may be eligible for exclusive tuition fee waivers, discounts, or application rebates with our partner universities. If you're not sure where to start, just head to eduadvisor.my. We're also everywhere on socials, so stay connected with us on TikTok and Instagram for campus insights and fun education content. And don't forget to follow our WhatsApp and Telegram channels for updates on upcoming webinars. Without further ado, let's get into today's topic, which is data science versus computer science versus IT. What's the difference and how to choose? It's my pleasure to introduce our esteemed speaker who will be speaking on today's topic, Associate Professor Dr. Tan Chin Ike, Head of School of Computing from APU. Hi, Prof. Ike. Thank you so much for joining us
Hello.
today.
Thanks for having me.
All right. Prof. Ike, since would you like to do the honors of introducing yourself, or
All right.
you can just go ahead and start with the session two if you want?
All right. So, hi everyone. My name is Ike, and I'm going to share a little bit about the world of computing. Right. So generally, I will also explain what is the difference between the terminology computing, computer science, and software engineering. Yeah, so Asian parents love the word computing, right? Because it really sounds respectable. And I think in Asian culture, certain words actually automatically sound safe and automatically is considered a good investment, right? Like lawyer, doctor, pilot, right? So when you say things like, or when parents say things like computer science and software engineering, yes, two very important words, right? Science and engineering. And in the eyes of Asian parents, or rather Malaysian parents, that translates into money, right? So that's all about money, right? So, okay, a little bit of introduction of myself. My name is Dr. Ike. Yeah, a lot of people just call me Ike. That's IKE, just one alphabet short of owning IKEA, right? I always start my presentations this way, especially for orientation, until one of the students one day they say, "Hey, IKEA, is that why your head is shaped like a Swedish meatball?" Anyway, okay, so I'm the head of school at the School of Computing at Asia Pacific University. I'm also the chairman for the Association of Computing Machinery, ACM, for Kuala Lumpur chapter. And I'm a professional technologist. I've been in this line for the past 25 years. Prior to that, I was in industry. The School of Computing at Asia Pacific University runs basically computer science, software engineering, information technology, and information systems. I'll explain a little bit about what those things are. But before I start, I'm going to just share these two things, right? What I call the two most important facts in, right? Number one, technology has evolved more rapidly in the past 50 years than any time in the previous 200 years, right? Number two, our reliance in technology has grown, right? Over the past 50 years than any time in the past previous 1 millennia, right? The 1,000 years, right? So technology has grown and our reliance in technology has grown as well. Well, basically, I wanted to share this in 60 seconds, right? Every 60 seconds, an astounding amount or quantity of content material is either created, is consumed, is shared, and is fed throughout the globes. And if you look at it, so I'll give you a few examples, right? In 60 seconds, nearly 700,000 Instagram stories or reels are posted, right? And over 40 million WhatsApp messages are sent. And with over 1 million users active on social media platforms at any one time. For content consumption, for example, there are over about 500 hours of videos being uploaded on YouTube, while in 60 seconds, millions of hours of content are being watched. Right? For the terms of e-commerce, right? in 60 seconds, over about 40 over million dollars are spent online globally, right? Including half a million on Amazon, about 400 million in treasury bonds, so on and so forth. And on the AI front, I think ChatGPT receives about 7,000 prompts every 60 seconds. Gemini attracts over 8,500 visitors. So there's an incredible amount of uh, technological content being shared and being used at any one time. So we are super hyper reliant on technology. Now let me go back in time a little bit, right? And this is something called the Industrial Revolution, right? And there are basically four revolutions, and revolutions basically means at any one time where our way of life has changed, right? How we treat our consumer behavior, how technology moves, uh, basically drastically changes society. And I think but the first industrial revolution happened in the late 17th century, right? What happened? The invention of steam engine, the mechanized production, textile factories. Many years ago, during that time, factories before the first industrial revolution, a lot of products in, for example, your shirts and your clothes, that happens at the cottage industry. Small little houses, small little family-run business. But because of steam engine production, textile factories, it actually allowed the mass manufacturing of goods. So the shift came from agriculture, growing stuff, to manufacturing, producing stuff, right? And at the core of the technology was the steam engine. So we moved from manual labor, from manually sewing things, to huge machines like the top left hand corner, where we could do automatic sewing, right? Textile weaving, so on and so forth. And this revolution established a pattern that would change society over the next 400 years or 300 years, right? The fact that technology transforms productivity. So that's the first industrial revolution. And then we move on to the second industrial revolution. We talk about the electrification and mass production, right? So electricity, assembly lines, mass production, where instead of one person working on the entire car, you get a group of people working on the tire, another group working on the chassis, another group working on the body, another group working on the engine. So what happens is because they are doing only one thing, they get really good at it and therefore faster at doing this. Right? So electrical technology was the brains and the power behind this. And this is where we start thinking in the area of processes, efficiency, and systems. And that later changes, that thinking comes into being in terms of software systems and process automation, so on and so forth, right? And then we have the third industrial revolution, and that happens in the 1960s, yeah, onwards. And what happened? That's where we see semiconductors, computers, automation, and the internet. The core technology that made this happen is electronics and computing. And the third industrial revolution basically digitized the entire world. We are now currently at the fourth industrial revolution. And what is it actually? It's about intelligent systems. It's about connected systems. It's about AI, big data, Internet of Things, cloud, and robotics all working together, right? Now we rely on machines to learn, predict, adapt, optimize, right? And this is where technology is not by itself, but it all converges together, right? Some people also say now we are actually living in the Industrial Revolution 4.5 or even 5.0, where AI, agentic AI, and everything which is AI driven is at the core business of what we do, right? And why am I sharing with you all this? It's because at the end of the day, I wanted you to know that technology drives innovation and technology drives our society. Remember earlier on, I was saying that, yeah, we are so reliant on technology right now. over the next 20 years, we'll be more and more reliant on technology. So the big show of hands, how many of you at least use ChatGPT once a day, right? Can you do without ChatGPT? Can you do even without your internet or your data or your handphones? We can't, right? It's technology has actually weaved itself into our lives, right? So yeah, uh, so the most important part of technology, especially with the second industrial revolution and the third and the fourth, is computing, right? I know most of you are asking now, right? What is computing, right? And thing is, a lot of people think that computing is about using a computer, right? Computing is not about using technology. It's never about using technology. Computing itself is about creating, shaping, controlling, and solving problems with technology. So basically, if medicine is about human bodies and law is about rules and systems, then computing is all about logic, systems, and solving problems at scale, right? In simple terms, actually, it's like saying lah, computing is actually teaching stupid machines to do smart things. Because machines itself are pretty stupid, right? I hope the recording is not being archived because 100 years from now, the computers, when they become alive, they're going to hear me say that and they're going to kill me, right? Yeah, so anyway, computing is all about problem solving, it's all about systems, right? Now, computing itself is divided into four major areas. Yeah, so the Association of Computing Machinery states that computing is divided into four areas. Now, I've showed this little picture here. At the very left section is what we call the electrical and electronics engineering, right? And everything that we see, everything that you look up, if you look up, you see your aircons has electronic components. You look at your fans has electrical components. Your kitchen, your toaster has electrical components. Everything has electrical components. We have things which have electrical components. We have things which uses electricity. We have things that has a battery. So E&E is all about the study of electrical and electronics, right? How it works together with telecommunications, so on and so forth. And then you move on to computer engineering. Computer engineering is like E&E, but it's more focused on anything computer based. So your motherboard, your RAM, your BIOS, your GPU, right? Your CPU, right? Anything to do with the hardware and the software components of computer engineering, right? Of computers, right? So it's E&E, but focus on computers. And this is what we call the hardware aspects, all right? Now, understandably, they also do a little bit of programming, but by and large, they deal mostly with hardware components, right? Transistors, chips, right? And then you move on to the computer science side of things, right? So computer science, and then you have software engineering and IT and last information systems. Now I know some of you may heard of things like cloud engineering, you may heard of things of AI, you may have heard of data science, cybersecurity, but in all those things falls under these four components. So let me go one by one to explain a little bit about what each of these are so that you understand what is the difference between, for example, computer science and software engineering, or IT and information systems, or even computer science and information systems, right? So basically, computer science, we take the nomenclature science. What do scientists do? So what do scientists do, right? Scientists is all about asking questions, right? Uh, it's all about solving problems. So scientists probably ask things like this, right? How big is the universe? How old is the universe? Right? What is the smallest thing in the entire universe? And these are not small curiosities, right? These are fundamental questions or foundational questions that have driven humanity for centuries, right? It's what I call structured curiosity, right? So what is the smallest thing in the entire universe? Come on, guys. Actually, if you text, I cannot see anyway, right? Some of you may say, yeah, smallest thing on the entire universe is a virus. Some of you may say, okay, no, it's not a virus, it's a molecule. Some of you may say that smallest thing in the entire universe is what? Bacteria, right? It's for centuries human belief that the atom, right, was the smallest indivisible unit of matter, right? So the smallest thing in the universe is actually an atom. And basically, atom actually is a Greek word for uncuttable, right? Cannot be cut, right? But scientists kept on asking, okay, fine, what's smaller than an atom, right? So experiments in the late 19th and the earlier 20th century revealed that actually, atoms were not solid spheres. Yeah, they are not solid materials. They are structured systems made of smaller components, right? Basically, what's an atom? It's an electron orbiting, and it not orbiting in a very traditional manner. It's just being present at any one time, right? Electrons orbiting a nucleus, which composed of a proton and a neutron, right? And that those are what we call subatomic particles, right? Yeah, and let's take, for example, the behavior of electrons, the negatively charged subatomic particle, which is the foundation of all modern computing. When scientists actually understood how electrons move through materials, we then develop semiconductors. When we understood the quantum behavior at quantum mechanics at subatomic level, we then built transistors. And when we found a way to miniaturize transistors down to the smallest possible level, we created microchips, right? Today, every computer, every smartphone, every cloud server, every AI system, every handphone that you use, every electronic product exists because scientists ask the questions: what is smaller than an atom? How does an atom behave? And how do electrons behave in matter, right? So yeah, the smallest particles in the universe have enabled the largest, most prolific systems humans have ever built. Science begins to ask about questions. Science is all about questions, right? And technology grows from the answers. So, what is computer science? Computer science is a science of computation. It studies how computing works at a very fundamental level. Computer scientists, they don't deal with applications or software. They deal with ideas. They ask about things, how things work, how efficiently they work, and what is theoretically possible, right? If you like logic, if you like maths, if you like abstraction, if you like to go in depth, then this is a field for you. It's basically the science of computing, right? And basically, we deal with maths. You have to be good in maths, right? You have to be good in logic, okay? Yeah, so computer science, if I had to say one word, computer science is about coming up with ideas that make computing technology possible. That's computer science, right? And inside the domain of computer science lies AI. Inside of the domain of computer science lies data science, cybersecurity, operating systems. What? Yeah, the newest Windows, right? Windows 12, Windows 13, right? The newest iOS, the newest forms of biometric security, right? Bioinformatics security, so on and so forth. That's computer science. Okay. Next up is software engineering. Okay. Basically, we take the nomenclature engineering. What do engineers do? Well, basically, engineers invent things, but mostly they improve on existing things. So, computer science is about why, right? They ask the question why. Software engineering is about how, right? Software engineers turns ideas into real, scalable, and usable software. If you like structure, if you like processes, if you like building things at scale, if you love programming, you don't mind seeing lines and lines and lines of code, then this is for you. Software engineering is about building reliable software systems. Okay, so I like to give this analogy, right? Computer science is about discovering electricity. Software engineer is about building the power plant, right? One is discover the theory of electricity and how electricity works. Software engineering is the one that builds the power plant that powers the entire city and so on and so forth, right? So that's an example, right? Next up is IT. So what is IT? Basically, it is computing within an organizational infrastructure. Okay, it's the reason that your schools and your colleges and your office, if you're a parent, still functions. Okay, software engineering. If software engineering is about building the building, IT is about ensuring that the building has electricity, that the doors lock, that the CCTV works. It is a combination of hardware and software. They don't develop programs, they don't develop applications, they don't write codes, but basically they use tools, existing tools, right? Servers, right? How to configure servers, how to configure the routers, how to make your laptop work, how to reinstall Windows, how to solve problems whenever problems crop up, right? So they are the ones making companies which rely on technology work. All right. And last but not least is something we call information systems. It's a cross between computers and business, the intersection between business and technology. So remember, software engineering, computer science is about asking why. Why does this thing work? Software engineers is about asking how, right? IT is about how do we implement it to work in an organization. Information systems is basically they ask how does this system help grow a business, or how does this system or how does this technology help to make this business more efficient, right? So if you love computing stuff but you don't really want to do programming, you don't want to deal with hardware, and you want to do a little bit more of the business perspective, then information systems is all about you. Information systems is to ensure technology solves business problems strategically, right? If IT is about installing the system, hardware and software, information systems is about deciding why a company needs the system and how can a company grow with the system and how can the company be more efficient with the system, right? So generally speaking, computer science and software engineering is what I call hard computing, right? They require additional mathematics, right? And programming skills. Computer science requires a little bit more maths. They use more maths than programming, right? Software engineering uses more programming than maths, all right? Information systems and IT are what we call soft computing. You don't require additional mathematics, just normal mathematics, right? But they don't deal with developing systems, inventing new systems. It's all about using the systems. IT uses the systems to grow an organization, to make an organization more efficient, while information systems grows the organization, right? Makes it more their business more profitable, for example. So, if I have to recap, computer science asks this question: how does computing technology work? How can we make it work better, right? What's next, right? Software engineering is all about building reliable software, right? So your applications, you go to the restaurants, you see the QR systems, you scan the QR code, it goes to the kitchen knows what you ordered. When you go pay the bill, they know how much everything comes up. Those systems are developed by software engineers. IT is all about how do we deploy and how do we manage technology. And information systems, how do we use technology to create business value? Right? So these are the four components. Okay. Now I want to emphasize a little bit about two of the most important areas right now of growth. Number one is AI. right? And number two is data science, okay? And we all use AI. Everything has AI now. Even if you don't use ChatGPT, even if you don't use DeepSeek, right, or Gemini, AI is present. Even in things like your Instagram, right? They know what your surfing habits are. They know what you have searched. If you have your Netflix and your Amazon Prime, right, and your Disney Plus, they know the types of shows you watch and they try to recommend shows which fits your profile. This under the hood, this is all AI, right? So the big question: have you ever asked yourself what is AI, right? Um, yeah. So generally, AI and data science is not standalone buzzwords. They sit on top of very strong computing fundamentals, right? AI focuses on machine learning, intelligent systems, perception, prediction, automation. Basically, this AI is a field of computing that focuses on building applications and systems that can perform tasks that normally require some form of humans, right? Or human intelligence, right? Yeah, so an AI itself is divided into, ooh, okay, someone came in, four areas, right? We have something called the narrow AI or weak AI. We have something called the general AI or strong AI. And there's something called super AI. So what is it, right? So narrow AI is basically AI that can do only one task, right? Uh, it cannot operate outside its trained domain. We train it and it can do that one task. Okay? Like your Roomba, your little automated vacuum, it can only vacuum, right? It can't get up and make you breakfast. It can't get up and close the door or operate the security systems. It can't. It can only do one thing. Similarly, right? Okay, I won't go there first. I'm going to ask this question later, right? Next up is general AI. And general AI is something that is supposed to be theoretically equivalent to human level cognition, equivalent to human level thinking, right? It's basically a computer version of a human, right? Yeah, you and me, right? And last but not least is something called super AI. Super AI is something that surpasses human intelligence, right? In the form of reasoning, they can reason faster and better than humans. They are more creative than humans. They are more. They can discover things better than humans. They can strategize better than humans. They can exist in multiple domains in multiple places at one time, right? So they can think of couple of things at one time in a super fast speed, right? That is super intelligent AI. So let me ask this question. I know all of us have can chat here. What do you guys think Chat GPT is? What do you think your uh, Gemini is or your DeepSeek? Is it narrow AI? Is it general AI or is it super AI? Okay, we're going to come back to this question in a short while. Now, I have created a little image here, right? So let me just ask this question. I'm going to open, I can't see the chat. Oh my God. I can't see the chat. Oh, I can. Okay, I'm going to click here. Which of this do you think is, can I see the chat? I can't see it. Okay, everyone. Which do you guys think is weak AI? The Roomba. Awesome. Okay. All right. Which Optimus Prime? What is he? Is he a super AI? Super AI. Hmm. So let me ask this question. Can Optimus Prime be in three places at one time? If he is super AI, wouldn't he be able to destroy, or wouldn't Megatron be able to destroy humanity very, very easily? Does Optimus Prime has emotions that can cloud his judgment? Hmm. Right? So we call Optimus Prime, the science fiction level of Optimus Prime, basically as general AI. They behave like humans. They have achieved human intelligence, right? They have achieved they have emotions, right? Some form of sentience, so on and so forth. That's general AI. Now, the last one, super AI, is this on the bottom right hand corner. Now, I'm not sure how many of you have watched this movie. Can any of you tell me what movie this is? Probably not. Yes, Matrix, correct. This is Agent Smith. Now, Agent Smith is what we call a super AI. Why? Because in the second Matrix movie, he can replicate, right? He can replicate himself to 1,000 Agent Smiths. Each Agent Smith is capable of independent thinking, right? They can think faster and beyond human capacity. That is actually generally what is super AI. So for us, right, humans, we think in 3 dimensions, right? We can't understand another level of the fourth dimension, right? Fourth dimension is space time, for example. Fifth dimension is I don't know what. But super AI is probably something that can understand in 4 dimensions, 5 dimensions, 6 dimensions, 7 dimensions. So let me ask this question. Where do you think we are at right now? What is ChatGPT? Do you think ChatGPT is super AI? Okay, some wrote general AI. Okay. So, question, right? I want you all to go back later on and try with all your AI tools. Ask them, what time is it? What day is it? They can't answer that because they only come on when you need them. When you type a prompt, they respond to the prompt. Other than that, they are not functioning behind the screen. They have no emotions. They can't think for themselves. They don't know how to self-replicate. So actually, ChatGPT is also considered a narrow AI. It can do what it has been told to do. Right? Hmm. Okay, so yeah, that's the area of AI. We are about a long time away from general AI. We are still at narrow AI. We haven't created an AI uh, that is self-aware or is at human level thinking. We haven't yet. Okay, maybe 5 years away. Super AI, not even close. The day we invent super AI is the day when Terminators come in and kill us all. Okay. All right. So yeah, that's a little bit on AI. Right. I'm going to move a bit fast because I realize a little bit short for time. Okay. Second one is data science, and data science is a discipline about extracting knowledge, the insights and predictive power from data, right? It's about extracting data and understanding and using the data to come up with knowledge, insights, and predictive power, right? And we use statistics, computing, and domain expertise in it. So, what are all these data used for? What's this knowledge used for? What's this insights used for? It's basically to grow a business, right? So basically, data science is about using data to grow or to understand something that's going to happen in the future. So it's all about prediction using massive amounts of data. It combines statistics, programming, and machine learning, right? And data science is split into 3 areas: data analytics, data engineering or data architecture, and data science, right? So data analytics, you get all the data and then you analyze it, right? What happened? Why is people doing this? Why did it happen, right? It's all about analyzing the data. Data architect is about building the systems that collects the data or cleans the data or stores the amount of data, right? The massive amount of data. And data science is all about understanding the data, finding a pattern, and predicting what will happen, right? what can happen, based on this information, what should we better, how can we best prepare ourselves for it, right? So it's all about prediction. It's all about building prediction models, okay? And a lot of companies are using data science now in order to understand how to grow their business, using all this data to grow their business, to predict where their business should be in the next 6 months or 1 year, right? So, having said that, data science is an incredibly fast growing area. I want to show this to you right now, right? This is what we call the rate of automation. Okay, and 6 years ago, um, a lot of the things in factories and in businesses, in organizations, it was done by humans. 67% are mostly done by humans, while 33% are done by machines. So these are automation from your email, automation, even your when someone sends you a spam, right? It automatically rejects or something like that, right? So it's only 33%. In 2025, it's close to 50-50. In the next 2 years, we will see automation or machines overtake humans. And this comes to the most important part. This, right? Yeah, by 2025, actually they said okay, by middle of this year, 85 million jobs will no longer be relevant, right? Will be displaced, taken over by technology. Actually, to be short, taken over by AI, right? Things like accountants, auditors, well, not in Malaysia yet, maybe in other parts of the world, right? Data entry is totally being replaced right now, right? You know, the operators, telephone operators, all these are being replaced by automation, technology, and AI. But don't despair. While 85 million jobs are being removed, there are 97 million jobs being uh, introduced, right? And these are all in the areas of technology. I wanted to show this also with you all. It shows that, in all the businesses, right? These are AI and information processing technologies, big data, VR, AR, right? It's 86% of companies actually going towards that, right? 50% for robots and autonomous systems, right? And what this tells you is that AI, robotics, energy technologies, software engineering, data are the ones that are going to be at the forefront of businesses. The businesses that don't use AI, the businesses that don't use data science are the businesses that will not grow, that will fall behind, drastically behind. And I'm not sure whether you've heard of the story about Kodak, right? Kodak Films used to be the leader, the industry leader in film, but because they didn't innovate fast enough, they didn't uh, think about technology fast enough, they were replaced, right, by digital cameras, and it's going to be the same with every company out there right now. So what does this tell you? It tells you actually, at the end of the day, the top growing jobs are all in the area of technology. If you look at the top five jobs, it's big data, fintech, AI, software, security management specialist, right? And the top five declining jobs are everything that computers can replace, right? Want to share with you this as well. These are the five jobs that will massively grow by 2030, right? Data scientists, software developer, AI engineers, medical practitioners, right? So yeah, this is remember the time we began the entire thing by talking about how we are so reliant on technology, right? And how technology has moved more rapidly in the past 50 years than any time in the previous few centuries. And in fact, right, if you look at it, technology will evolve more rapidly in the next 2 years than any time in the dawn of humanity, with AI being at the forefront of everything. So that's why, if you look at the five jobs that will massively grow, the middle three, data scientist, software engineer, an AI engineer, these are the jobs that will be incredibly in demand. Okay, gonna skip this, all right? And yeah, a little bit about just to share with you all. Yeah, this is a slide that I shared. Why should people join APU? So I don't know whether it's appropriate, but anyway, at APU, we actually offer the entire range of computing, right? Disciplines, everything from IT, and even IT also, we have the components of IT. So, cloud engineering, Internet of Things, fintech, financial technology, right? Networking, right? Right up to software engineering, computer science with data, computer science in forensics, computer science in cybersecurity, and computer science in AI as well. And I wanted to share this with you, quite interesting, right? Again, focus on data analytics and AI. Um, I'm sure most of you are asking, okay, if I study this, what is the basic salary I'll get, right? So I just wanted to share with you. Uh, for this company called Derive is a multinational company. Four of our graduates last year just secured a job in Derive. Fresh graduates, huh? Guess how much they earn. Okay, come. I'm gonna ask you. Guess how much a fresh graduate will earn, right? In the area of AI. Come on. Oh, okay. Some of you are quite high. Some of you got it right. Yeah. This four of them, they got about 6,000. 6,000. Okay. Now, what about data science? Okay, these are AI. Data science, I found out last year, in a company called British Petroleum. Data scientist, fresh graduate, 8,000 ringgit. Fresh graduate, right? Then I was also a bit amazed. I said, wow, but this is a multinational company, it's oil and gas. And then I found out for another company called Touch and Go, it's about 7,000, 7,500. Yeah, so these are the two career paths. Yes, of course, they're first class graduates. I mean, you get paid based on your talent and your skill sets, right? And your area of competency, right? Yeah, so okay. Uh Time really flies, oh. Nina, this ends what time? At 6, right?
Yes, it doesn't end at 6 actually because we do have our Q&A. We
Right,
can
okay.
extend a little bit, yeah.
Okay, yeah. So back to this, right? So computer science, it's all about the science of computing, right? They take nomenclature science, and they push the boundaries of computer technology, right? So it's all about experimentation, all about research, all about testing, right? In order to come out with something new. So again, AI is computer science. Cybersecurity is computer science. Operating systems is computer science. Uh, Data science is under computer science, right? Next up is software engineering. Software engineering is all about programming, developing systems, testing systems, deploying systems, right? So the difference between computer science and software engineering is this. Imagine a computer scientist is the one that creates a car that runs on water. Never been done before, right? Amazing. But the problem with the car that runs on water is there's a 50% chance of it exploding. It costs $5 million. It can go only about 10 kilometers per hour. But to a computer scientist, I don't care. I have pushed the boundaries of human technology and invented a car that runs on water. Wow, right? It is a software engineer that will make the car safer, more efficient, more cost effective, right? It is an IT person who would do the maintenance on the car that runs on water, how the engines and everything. Whenever the car has problem, he will fix the systems and everything. And it's an information systems person who will figure how do I monetize that? How do I make money off that? How is the best way to make a money for a car that runs on water? Because then you don't need petrol anymore, right? Maybe they'll set up places that gives a specific type of clean water, for example, So things like that. All right. So these are the domains of computing. All right. So I'm just gonna move right up to the end right now. Okay. You can scan. If you have anything to ask me, this is my Instagram. Yeah, feel free to Find me on Instagram. You can ask me any questions. Do follow me. I'm trying to be a part-time influencer. Haha. All right. Now, I'm going to take this time right now to answer all the questions.
Okay, all right. So we'll just start with the first question from our audience. This is from Asma. They asked, what is the difference between software engineering and computer engineering?
All right. So computer engineering is about remember about I was telling you about electrical and electronics engineering? It's about how the chips work, how the hardware components work. So computer engineering is about that. How do I engineer better motherboards? How do I make the motherboards communicate better with the RAM, your GPU? So it's all about the components of a computer. It's actually hardware. Software engineering, well, term software engineering, lah, right? It's about developing software for businesses, right? So all your, for example, if you have your handphones with you, your WhatsApp is developed by a software engineer, right? Your Outlook, that's developed by a software engineer, right? Your Excel, your Microsoft Words, that's all developed by a software engineer. So they're the ones who are developing applications and systems, human resource softwares, right? In companies, they have all this software. In your schools, your attendance systems, that's all developed by software engineer. So computer engineer is mainly hardware. They do a little bit of software in terms of BIOS and assembly language, whereas software engineer is all about software, testing of the software, developing the software, so on and so forth.
Understood. Okay. We have the next one from Najla. They asked, I've heard about broad AI. Could you enlighten us about this?
Broad AI. Broad AI is actually general AI, actually. So you
Mm.
have narrow AI, which is weak AI, broad AI, which is general AI, which is also called strong AI. Okay, and the third is of course super AI. So it's actually just three only. So we haven't reached the broad AI yet. Now, this could be a nomenclature problem as well. So some people say broad AI also is AI agents, but that's a different terminology altogether.
Okay, understood. Moving on from Megan, she asked, would it be beneficial to mention on my resume my participation in hackathon events, even though I didn't win any prizes or awards?
Definitely. Why is this important? If you're a fresh graduate, and you apply to a company, as a company, right? I see hundreds, if not thousands, of resumes, right, every week. Especially if it's fresh graduate. Fresh graduates, all you have is your resume and your CV, right? And all you have there is which university you graduate from. Now, to be honest, most of the universities are all the same, right? The only thing that sets you apart is what you have done. And that's where APU's strength is, because APU, we make sure that our students participate in as many hackathons as possible. Now, hackathons basically means that you have uh, participated in an industry level event. You have done presentation. There are some levels of soft skills, and you have gone out beyond your comfort zone, right, to work together on competitions, right, within a fixed amount of time. So yes, hackathons, game jams, events, all this sets you apart from the other resumes. Of course, if you win, it's better lah. And how do you win? Participate in as many hackathons as possible, right? Don't expect you participate in one hackathon and win that unless you're really, 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 really awesome, right?
I think this ties to our next question from Lauren. How do I stand out as a computer science graduate in an oversaturated job market? I do want to add on a bit on this. Aside from hackathons and participating in extracurriculars in uni, what other factors can, I guess, a student include in order to stand out?
Okay, so a very, very good question. I just met two persons today, two companies today. One is a Dutch company, right? They are based in the Netherlands, and another is Google itself, right? And we had this interesting question. At the end of the day, let me just honestly tell you, what you learn in university, right, is never at the cutting edge of industry. Because even in industry also, they blink and it moves so fast, especially within the last 2 years, right? Now, so what universities do is this. They do two things. Number one is we teach you fundamentals. Fundamentals don't change. Maths have not changed in the past 2000 years. The other most important things we teach you, and these are the things that the companies actually say they value more than technical skills, are soft skills. Right? Soft skills are like what? Presentation skills, problem solving skills, learning how to work with other people. And this is something that they have actually brought up just now, just not more than 2 hours ago. The conversation is this company had problems where their students from other countries, they realized that, for example, in Vietnam, right, they can't really work with people from within the same company from Australia because the Australians, if you know the Australians, they are really, really vocal. They can be sometimes, they will say it, they're very frank people and they will say it as it is. And sometimes you don't get the sarcasm and you get very upset. Oh, he's scolding me. It's not like, whereas Asians are very polite, very, very demure. These are the things that soft skills train you to understand how to work in a globalized environment, right? Uh, and how is the best way we teach soft skills? For example, in APU, um, team projects, we have a lot of team projects. We have a lot of hackathons. We have a lot of industry projects. We bring you to visit. We basically, the purpose here is we open your eyes of the students to how industry does things, right? So problem solving, time management, conflict management, presentation, public speaking, business acumen. These are all skills that is needed to succeed for the rest of your life in the technology world. Okay, yeah. So, Lauren, how do you stand out as a computer science graduate? You need to have all these soft skills, right?
Hey, all right. Thanks so much for that, Prof. Next is from Muaz. I've seen this job analysis all the time, but particularly in our country, but haven't seen these jobs being implemented yet. Any thoughts on this?
Oh, I mean, have you searched data scientists? Data scientists, every single company is looking for data scientists. But the problem is sometimes the terminologies they use, right? Some they call it data scientists. For example, some they call it data architects. Some they use data engineers. Some they use data technicians. So different terminologies, but the actual job function is the same, right? So data scientists in core value, data architects, data analytics, definitely. I think this is going back to the five core jobs, right? Software developers, some people call them software engineers. Some people call it back end. Some people call it front end. Some people call it full stack developers. At the end of the day, it's still the same thing, right? AI engineers, some people call it AI programmers. Some people call it AI engineers. Some people call it AI specialists. Uh, Honestly, these jobs are being implemented. There are shortage of talents. And how do I know? 2 hours ago, I told you the Dutch company. I also met a Russian company. They're looking for 200 graduates, software engineers, and data scientists, right? They can't find, right? So they're approaching us and we are trying to supply them as much as we can. But they don't call it data scientists, they call it product specialists, right? Or product analysts, right? Yeah, so it's a different terminology altogether. Moas, I hope I answered your question. Do follow up with another questions if you can.
Right. We have one from Yip. I think it's in related to your fresh graduates on first class. I think you might have missed it as you progress with your presentation. How rare would you say is first class graduate in, let's say, 100 students?
It depends on the particular cohort. I mean, some cohorts we get 50% of the students are all first class, some is slightly less. So yeah, it all depends on a particular cohort of students coming in, right?
Okay. We have one from Asma. I think it's related to the
Yeah, it's the same.
program
I
that
think I've answered
AP.
that. Yeah, yeah.
Okay. Now it's from Yip still. Is it more suitable for outgoing people in software engineering and those yeah, in ITs, yeah, outgoing and software engineering at home?
Uh, I, I, my question is this. My answer would be this, right? Uh, Software engineering is something if you like doing, sitting in front of the computer, doing coding, right? Doing programming, lines and lines and lines of programming, right? 9 to 5. And if there's a little, if for those who have done programming, if there is a mathematical problem, if there's a dot missing or something like that, or operator missing, the whole system may not work. Or it may work, but it may not work in a way you want it to work. If you're the sort of person who don't mind sitting down for an additional 1 to 2 days or 3 to 4 days, right, trying to solve the problem, then software engineering could be for you, right? But then again, there are some people who go into something called technical sales. So they go into the sales component, but technical sales means they understand the technical components of the particular software or particular solution. If you're outgoing and you're very technical, go for technical sales. I know IT people who are basically not very outgoing, who are introverts, right? So yeah, it's all about your personality. I mean, data science as well. If you're an outgoing person, you probably can grow further to be a lead data scientist. So yeah, it's about any of these jobs can, when you want to climb out the value chain, it's better if you're a bit more outgoing lah. I wouldn't say outgoing. Outgoing is not a good word. A bit more extroverted, good in public speaking, good in understanding people, right? People management skills, so on and so forth. Yeah.
I think you can still be an introvert with those people skills.
Yeah,
So,
yeah, I tell people I'm an introvert, nobody believes me.
all right. This is from Megan. This is in relation to cybersecurity. What's the job market like for cybersecurity field, and what's the starting salary that I can expect as a fresh graduate?
Okay, good, very good question. Now, if you know, right, everything now, all our data is being stored online, right? We do online banking, we do transactions, your touch and go is real money, right, in the digital world. Our data is floating up there, our finances are floating up there. What does this tell you? It tells you then that because everything is on the cloud or in digital format, there is a pressing need for security, more and more cyber security. Because whenever there is money, there will be probably people who, 100 years ago, when banks first, oh no, not 100 years ago, few hundred years ago when banks started, immediately the first job that come out is bank robbers, right? Because there's money involved. So as when we start storing our finances online, that's where people are trying to figure ways of breaking into the system and stealing your money and data. Hence, cybersecurity becomes an important component. All right. Every finance institution, every audit firm, every accounting firm, every major corporation has some form of cybersecurity in its department. So yes, it's a market that's ever growing. And cybersecurity, there are many types, right? One is a type that will simulate attacks, right? They will attack on behalf of organizations to see whether is there any vulnerabilities in your system. There is another to defend. They understand how the firewalls and they stop people from coming in. And the third is the forensics. If an attack has taken place, what has been compromised? What has been stolen? So it's a major, major, major uh, field to be in, right? Starting salary anywhere from 4,500 to 5,000, depending on your what area of cybersecurity and where you're working. Right? If you're working for a multinational company, for a bank, it's really high. If you're working at cybersecurity for a smaller company, a SME, then it's probably not as high. Okay. I saw a message from Samantha Chan. How can data science be applied into the business world? All right. So, give you an example. So, what is data science is tied to something called big data, right? Big data is all about the data that is floating around right now. And we talk about trillions and petabytes of information that is floating. Remember that's now I said in 60 seconds, there's so many WhatsApp messages, so many videos being uploaded. All these are information, right? So how can it be used in a business world? All right. Let me try to think of an example. Uh, I give you an example from a data science perspective. So let's talk about if I use, let's say I just use something simple lah, right? Um, Netflix. Okay. Uh, your the way what movies you watch, right? I can know what kind of movies you watch. Okay, that's for one person. And then after that, I recommend movies, right? But right now, if let's say I'm checking on the trends and the mark and the viewing trends of 1 million people. Very easily, then I can tell Netflix can say, okay, they like this type of shows. Why don't we start producing this kind of shows? Why don't we start producing this kind of content? So similarly, for an organization, if I can understand the trends and the patterns of, for example, where do people travel? So if I can measure, if I'm Asia, and I measure all the flights of every single customer in Asia and where they are going, how long they spend, when is the period, the peak period. I can now understand that, okay, based on all these flight patterns also from MAS and everything, or better still, if I can find from Instagram every image that people have posted, right, on their holidays, I can do a prediction that okay, a lot of Southeast Asians are visiting suddenly Kazakhstan over the last 3 months. I can then start arranging for more flights there, right? So, for example, this could be an example of how data science could be applied in the business world. I hope I
Okay.
answered the question.
No, you did. I think that gave me a clearer picture of how big data and data science work. If we can move on to the next question. This is from Adam. What's the best foundation to choose to pursue data science and I guess the science tech path?
What's the best university to choose? APU. No, um, okay, or foundation. Okay. So after SPM, you have two pathways, right? So depending on whether how many credits you get, if you get more than 5 credits, then you do foundation, right? If you get less than 5 credits, then you do a diploma. Now, you have to understand what's the purpose of a diploma, right? What's the difference between diploma and foundation? A diploma is basically structured for you to finish diploma and work, right? So it prepares you for work. Whereas a foundation is to prepare you for degree program, right? So a lot of people don't like to do foundation because foundation actually, right, inside foundation, we don't really cover that much IT stuff or computing stuff. It covers there's a little bit of business, you learn psychology, you learn social science, you learn public speaking. And you go like, why am I learning all that? I want to become a software engineer. Why am I taking foundation? Remember what I said earlier about what's the most important skill set that tech companies are looking for? It is not the technical skills, it's the soft skills. The reason foundation exists and is to prepare students for their pathway in a degree program. That's number one. Number two, the reason why foundation is also very important is because, let me just ask this, how many of you all are from Sekolah Menengah Kebangsaan? SMK, SMJK. Now, let me ask this question. How many of you have done more than 10 public speaking? How many of you are trained to go out there and inside the class they let you not about exams, right? Let's talk about your opinions about a particular matter, about your feelings about a particular matter. We don't do that. It's very exam driven, it's very structured. We are based on the Prussian model, right? The old European model. Whereas if you compare the American system, they have show and tell, right? At the very young age, they are trained to have confidence to stand up and talk, right? So that's why I hope this is not being recorded or no one's going to see this outside the Western world, right? That's why you talk about the Westerns, right? Westerners, they are very clever. They are so confident that they can bullshit with 100% certainty and you believe it, right? Because it's the way of talking, right? That is very important. That's the things that we need to train our young people, the public speaking, the problem solving, right? The confidence, the of talking, right? Your adaptability. All these things are very, very important. And that is why foundation is important. Because remember, foundation is not trained for you to go and work. Foundation is there to make you go into degree. Diploma is there for you to go and work. Of course, diploma you can flow to the degree as well. Yeah, so that is the key lah. right? But it's all up to preference at the end of the day. If you ask me personally, I would recommend students to do a foundation first. And it doesn't matter what foundation you do, right? As long as you do a foundation. Okay.
Okay, all right. Thank you for that. I'll move on to Patricia. Does software engineering cover game development and web development? Can I take software engineering to pursue those jobs in the future?
Okay, software engineering doesn't cover game development. Game development is a specialized program by itself. Well, in APU, it's a specialized program. In APU, we have a computer games development, which focuses on art or programming, right? And that is it's basically software engineering with uh, the component of games involved, right? So it's very, very specialized. Now, some other universities actually have software engineering that covers game dev, but it's very, very small. Okay. And there's and our software engineering actually covers web development. Okay. Your next question, can you take software engineering to pursue those? Can. By the way, Batrista, Batricia, uh,
Patricia.
okay, Mr. B. Okay, I'm gonna call you. No, I mean, are you a female or male? Okay, B. I call you B. Sorry. Um, do you know that Electronic Arts is in Malaysia? Yeah, EA Sports, right? And EA Sports are looking for software engineers, by the way, to do their games because they are working on FC Mobile. And by the way, Battlefield 6 is also done, portions of it was done in Malaysia. Okay, by the way, why am I so passionate in that? My background is in games development. I'm the chairman of the Game Development Council of Malaysia. And I run the games development course at APU. So for those who are really, really interested in games development, maybe we can flash out my Instagram again, or you look for Ike, IKE.TAN. You can see I have a lot of games related posts there as well, right? For those who are interested in games. Yeah, but yes, you can take SE to pursue those jobs in the future as well. But if you want to do games, just focus on games as a specialized path. Yeah, APU has that. Yay. Okay.
All right. I'm gonna skip a few questions because I think
Right.
you've answered most of them. Just to let the audience know, this webinar is recorded and will give the recording to you once it's available. So I'm just going to move on to the next question. This is from Adam. At what point during your studies do we take certificates at Google and Microsoft sets to increase our qualification for better positions in our career?
So the certifications are divided into a couple of levels. You have the associate level certifications, which is usually for students, right? Those will give you some insights, but the ones that really stands out is something what we know as the professional certifications. And those you take it after you complete your studies, right? Because the exam fees are really expensive. It ranges anywhere from 5,000 to about $10,000. And those certifications are what we call professional certifications. Like Microsoft has MCN. Oh, shucks. I forgot what was it. I forgot it. MCSA? Yeah, MCSA. Microsoft Certified Software. Oh, I can't remember. Oh, yeah. Anyway, yeah. Or CCNA, for example, Cisco CCNA, or the Ethical Hackers, right? Yeah, CEH, right? Those are professional certifications.
Okay.
Oh,
All right. So I'm going to jump to the next one from Damia. How can we tangibly measure our soft skills?
how can you tangibly? Oh, wow. Okay. Certain soft skills are easier to measure. Public speaking is probably the easiest, right? Time management is probably the easiest when you are in university and you cannot submit your projects on time. Then you know your time management is not very good. Conflict management is measured when you are in a group project and suddenly you feel like throwing your computer at your group mates. Yeah, so probably not the best thing. So I don't know. Soft skills, there are many soft skills. Some are easier to measure than others. Uh, the most important soft skills is, well, not the most important, one of the easiest way to measure is your presentation skills, your public speaking skills. How comfortable are you to stand in front of others and talk? Your problem solving skills, how good are you at solving problems, right? Do you create more problems, or do you solve it? When people come up to you with problems, can you give them solutions? Right? And your solutions, is it in a very scientific manner of coming up with solutions, right? So like software engineering, the nomenclature engineering, engineers solve problems using a very specific process, right? They have a process of doing things, right? So if you can do that, then you know that your problem solving skills is pretty good. I don't know. I don't have the perfect answer for that. Yep.
Okay, no worries. Move on to the one from Audrey. As an SPM leaver, what projects can I do right now before college to improve coding skills or I guess stand out later on?
Okay, yeah. Most important, I think, learn Python. If you have not learned Python, pick up Python. See if you like, you can do Python, right? To stand out, yeah, I mean, one is a technical, one is the I wouldn't call it technical skills, or the fundamental skills, fundamental tech skills like Python, Java, C++, right? If you're going for software engineering, do take up C++ or C or Rust, right? Rust is going to be the next language. If you're doing data science and AI, it's all about Python, right? So pick those things up. Pick out skills like, actually, if you ask me, I'm digressing a bit. Anything you do, right? Even music, any hobbies you have helps you with your future career at the end of the day. The only skills that you probably will not help is your doom scrolling skills. That's not going to help you at all, right? So don't doom scroll. Pick up some skills, problem solving, Python, a language skill, right? Learn Mandarin, learn German, right? Pick up, yeah, Chinese, Japanese, right? Language skills will help you. It will open the doors for better opportunities as well. Yeah.
Hey, all right. So I think we've answered most of the questions in the chat from either during the presentation or previously in your previous questions. But I do have a few questions on my own, if that's okay, Prof.
Yeah, yeah.
All right. So my
Wait,
first
if
question,
you don't mind, I saw this interesting question. I would like to answer this.
of course.
May I know whether games development is a niche or highly in demand field within Malaysia? Okay. T Sui. So I'm going to name you a few games and you tell me whether you've heard of it before, right? Last of Us Part 2, Uncharted, Spider-Man, Final Fantasy 15, Street Fighter 5, Baldur's Gate 3, FIFA, Call of Duty Ghosts, Call of Duty Infinite Warfare. You may have heard of some of these games, but a lot of people don't know that portions of these games was done in Malaysia, right? Malaysia has now about 10 international, more than 10 international companies. Electronic Arts is one. We have Streamline Studios, the studio that did portions of Street Fighter 5 and Final Fantasy 15. We have Larian Studios, the studios that is a Belgium studio that did Baldur's Gate 3. We have Double 11, a UK studio that worked on Little Big Planet, Minecraft Dungeons, and this really strange game called Goat Simulator, right? They're in Malaysia, right? We have Bandai Namco, which is in Malaysia, so Tekken, Katamari Damacy. We have Codemasters, which is in Malaysia. There's about 10 international studios in Malaysia and approximately 90 local studios, right? In Southeast Asia, there are about 6 international students, including Ubisoft, right? So Assassin's Creed, Ghost Recon, right? They're in Singapore. Lightspeed Studios, which does PUBG, right? Koei Temco, right? They are all in Southeast Asia, and Southeast Asia is home to about 400 games companies. It is a crazy in demand field right now. Those companies are having a shortage of game artists and game programmers. So yes, game development is another path for you to choose from. Again, later on, if you don't mind, Nina, I would like to flash my
Yes.
the IG profile again, so that if you can have any questions, you can text me directly. All right.
Okay.
Okay. Yeah. Okay. So
All
back
right.
to you,
So,
Nina.
okay. So we have one more question from Laila. Is there a lot of job opportunities for data science in the medical field, or is it rather more towards AI, data science?
Data science in the medical field.
Yes.
Oh, to be honest, I don't have the data for that. Uh, I think data science is prevalent in a lot of fields. Specifically in the medical field, I can't answer, right? But
Okay.
Yeah, I mean, data scientist is, I give you an example. So my nephew studied chemical engineering in a top 50 university, went to Singapore and got a job as a chemical engineer. It's about 3,005 Sing, which you convert is close to about 10, 11,000 ringgit. Quite high, right? Then he found out a data scientist earns about 4,005 Sing to 5,000 Sing, right? That's about 15,000 ringgit. Yeah, so data scientist is a crazy growing field, right? Regardless of whichever particular domain it's in. Yep.
Hey, all right, Bayan, Prof, I can already answer this question, so I'm gonna ask you a couple of questions I have on my own. All right, so Prof, my question is, how does APU future-proof its curriculum in a fast-evolving field like AI? And another one is, what steps do you take to ensure students are equipped for the rapidly evolving tech landscapes in an APU perspective?
Okay. So before I answer that question, what I'll also say this. One of the major strengths of APU is that we teach computing in an ecosystem of other fields as well. AI, data science, computer engineering, software engineering, cybersecurity. So all these, a lot of other places, they teach it in a very focused domain, right? But computing doesn't work like that. Computing is actually an ecosystem, right? All these are connected in one way or another. So, because, for example, while APU has about 16,000 students, we may not be the largest private university, but we are definitely the largest computing university, right? So our numbers for computing itself, computer science, software engineering, cybersecurity, anything, it's about 10,000 students. So that means there is an incredible ecosystem working at any one time. Okay, I want to stop sharing first and go back to the screen. I don't know how to stop sharing. Okay,
I can stop sharing
okay,
for
yeah,
you.
one last opportunity to take the Instagram and okay, done. Yeah. So, how do we future-proof ourselves? We work very closely with industry. All right. Uh, we a lot of universities, you ask them who are your main customers. A lot of universities will say, yeah, students are our customers, parents are our customers. For us, the industry is our customers. So we just met. We've met a lot of today itself. We had three industry partners meeting, right? We find out their feedback from them, how our talents are doing, and we tell them this, right? And I always tell the companies this: hey, let me know what we're doing wrong, lah. Scold us if we need to scold us, right? Tell us how we can improve. Our AI program, we changed it once last year. We are going to change again. We keep on changing our syllabus to match the industry needs. So we call this currency. How current are us? Right? And we are very, very current. Right, so that is how we keep our staff. We ensure that our staff are also always we bring in industry people. We get involved in competitions because competition is the best way to understand what's the technologies out there. And our staff are also involved in the competitions. It's not to say we allow the students that hey, go off, go pergi main jauh-jauh, we play ourselves. No, our staff are also with the students in the competitions, hand in hand. We mentor them, but we learn. We are also learning at the same time, right? So yeah, that's how we ensure that we are future proofing ourselves. I forgot your second question, sorry.
I think you've answered the second questions
Right,
already, the
okay.
steps that you've taken. I
Yeah,
have one last question. It's a bit more general.
okay.
But what factors should students consider when choosing institution to study either of the programs that you've mentioned earlier?
Wow, okay. That's a very interesting. I think most importantly is this. Um, the neutral answer I always give is, yeah, go to the university and see if you like the university environment. If the environment suits uh your your type of personality. But on the more practical skills, go and check if you are going to study medicine, for example, you have to make sure that the university itself has a lot of medicine related events, medicine related focus, medicine related lecturers, medicine-related competitions, and it's all about medicine, right? Because you will thrive in an area that keeps on repeating and emphasizing itself. So, in that respect, APU is a technology university. If students are willing to, or wanting to go into the computing and technology world, APU is at the forefront of that because everything we do is technology. Everything we do is computer science, software engineering, cybersecurity, right? We have one of the largest, actually not one of, we have the largest cybersecurity program in Malaysia. 2,000 students in one cybersecurity program, right? So a lot of our investment is also in staff and facilities for the particular field. So yeah, if you ask me what's the short answer, we eat, we breathe, we live computing technology.
All right. So unfortunately, with a heavy heart, we've gone over our allocated time, so we won't be able to take more live
No.
questions. But before we close, do you have any final words of advice for students who are anxious about pursuing computer science or similar courses at EP?
Final word is advice is this. Whatever you do, persevere, right? Your next 4 years of your life, right? The next 4 years determines the rest of your life. It's your most important pathway is not choosing what program you do, because there is never the perfect program that you say that, you choose computer science and after a while you go like, I don't like this, I want to try something else. You will never end, right? Choose something, stick with it, be the best that you can be, right? And remember that, yeah, you have 4 years to really set yourself out. Yeah, so the 4 years that you study in university is most important. A lot of people in university, they don't come to university. They say, I want to work at home. They don't interact. University is the best place, number one, to build your networks, not only with industry, but also with your fellow peers, because these are the people that will later on, be your colleagues, one day be your bosses, your seniors will be your bosses, right? Your juniors might even be your bosses one day. Network, build the networking. That's very important. Hackathons allow you to build networks with outside university as well and industry. So make the most of university life.
Okay, all right. So I think that's the end of our session for today.
All
Thank you
right.
so much, Prof. Ike, for sharing your valuable and engaging and interactive webinar with us and insights with us today. To our audience watching, thank you for your participation. It's been a pleasure having you with us. If you have further questions about computer science or EPU, you may send your queries to us at webinarcentral.support@eduadvisor.my and we'll answer your questions there. Or you can also just message Prof. Ike on Instagram.
Yeah.
So we
Go
hope
through EduAdvisor. Go through
EduAdvisor as well. So we hope you've gained some information from this session. Prof. I, it's been an honor and pleasure to have you with us. And we hope to see you again, maybe in our next computer science topic, in our next series. And have a good one, Prof. I.
Yep, and to everyone celebrating Chinese New Year, yeah, Kung Hei Fa Choi. For those who are traveling, please be safe, right? And most importantly, have fun, right?
All right.
Yes.
Bye, Prof.
Bye bye. See you.